Mrs. Carnahan. Today we're going to do the 1.3 notes over distance formula and midpoint formula, and we're just going to focus today on finding the distance between 2 points on a coordinate plane and finding the midpoint between 2 points on a coordinate plane, and we'll deal a little bit more with midpoints. But first let's talk about distance. So what is the distance? The distance between 2 points is the length of the line segment with those points as its endpoints. So basically if I have a point and another point, the distance between those 2 points is the length of that segment if I were to connect one point to the other point. Okay? Pause the video if you need to more time to fill that in. Okay, we're going to skip distance on a number line, and we're only going to talk today about distance on a coordinate plane. Okay, so you can turn to the next page when you're ready. We're going to do an example of distance on a coordinate plane first. So I'm going to plot these 2 points. It's 1, 1 and 5, 4. So 1, 1 and 5, 4. Okay, so what I need to do is basically, if I'm finding the distance, I'm finding the length of that segment between those 2 points. Now, how am I going to do that if it's on a diagonal? Because if it's on a straight line, I can, like if it's on a horizontal or vertical line, I can just count the boxes, but I can't do that when it's a diagonal. But something we can use is a right triangle. So I'm going to show you how I can find that distance if I make a right triangle with my horizontal distance and my vertical distance. So if we count over, this side on the bottom has 4 boxes to make that side, and the one on the right side has 3 going up, so it's going over 4, up 3 to get from one point to the other. But what I want to do is I want to find that third side. So to find that third side, what I can do is use Pythagorean theorem, because this makes a right triangle. Now what is Pythagorean theorem? Let's make a little note on the side. Okay, if I have a right triangle and I have 2 legs, we'll say A and B for their lengths and C for the hypotenuse. What we can do is use Pythagorean theorem to find that third side. It's a squared plus b squared equals c squared. So I take the 2 legs and I square them and add them, and that would equal the hypotenuse squared. So because I have the 2 legs on that coordinate plane when I made that triangle, I can plug that in for A and B. So 4 or 3 would be my A. It doesn't matter which one's which. And the other one would be B. That makes X my C, what I'm trying to solve for. That's the hypotenuse, that diagonal. So now I can plug in 4 squared plus 3 squared equals c squared. Now when I square that, I get 16, 4 times 4, and 3 times 3 is 9. When I add those, we get 25. And then to solve for c, I would take the square root. Now if I could simplify that radical, I would, which I can. It's 5. Square root of 25 is 5. So that tells me the length of that third side, that x, is 5. Okay? Alright, so one way is using Pythagorean theorem, using a graph. I'm going to show you when you don't have a graph how you can find the distance between the 2 points, and that would be the distance formula. Okay, so for distance formula, this is a generic formula given 2 points. So you'll notice on that picture we have x1, y1 for point P and x2, y2 for point Q. Those are just labels of those ordered pairs. So it's just saying like my first x value, my first y value, and then my second x value, my second y value. So in the formula for distance, I have d equals for distance. It's the square root of x2 minus x1. So basically the difference between the 2 x values, which is that horizontal distance that we got for on the first one, we got A is 4, that was the horizontal distance. It's basically subtracting your 2 x values. We're going to square that, and then we're going to add the difference of the y values squared. So y2 minus y1, and then we're going to square that. Okay, so it's basically derived from the Pythagorean theorem. Okay, we took the square root, we squared two numbers, and well, we squared them first, we added them together, and then we took the square root. That's basically what we're doing here. We're just taking the difference of those ordered pairs to figure out what those two numbers are. Like in the first one, we got 4 and 3. We need to find those numbers when we don't have the coordinate plane in front of us. So we're going to do a couple examples of that. So first, what I want you to do is label your two ordered pairs. We're going to label them x1, y1 for my first ordered pair, x2, y2 for my second one, so I remember which value goes where. Okay, I'm going to plug that into distance formula. We have square root. I'm going to take my x2 minus x1, so x2 is 3, minus x1 is negative 4. We're going to square that, and then plus y2 minus y1, so negative 1 minus 1, which is y1, y2 minus y1 squared. Okay, so now from here I just need to use my order of operations. Start with your parentheses first. So I'm going to start with that subtraction. We have 3 minus negative 4, that's going to turn to plus positive 4 to get 7 squared. And then on the second one, we have negative 1 minus 1, that's negative 2 squared. And then don't forget to add in your square root. Now I need to do my exponents next, so parentheses, exponents, we're doing PEMDAS here. I'm going to do my 7 squared first, which is 49, plus my negative 2 squared. Now a negative squared will always be a positive at this point. You shouldn't have any more negative values because we can't take the square root of a negative. Alright, so at this point, 49 plus 4, we can add those, and we get 53. Now, if I could simplify that radical by using the factor tree, I would, but that is a prime number, so we can just leave it like that, square root 53. Okay, we're going to do one more example. Okay, so for the next one, let's start by labeling our ordered pairs, x1, y1, x2, y2. Okay, I'm going to plug into my distance formula, square root. We have x2 minus x1, so 7 minus 13 squared, plus, take my y2 minus y1, so 10 minus y1 is 2 squared. Again, same order of operations. I need to do the parentheses first, so I'm going to do that subtraction of 7 minus 13 to get negative 6 squared. And then we have 10 minus 2, that's 8 squared. Okay, now I'm going to do my squared, so we get negative 6 squared should give you a positive 36. And then 8 squared we get 64. And then when I add those together, we should get 100. And then take the square root of 100. We can take that evenly, so I'm not going to break down the radical. Square root of 100 is 10. Okay, that's it for distance formula. We're going to talk next about midpoint. Okay, if you want to try that second problem, you're welcome to. The answer for number 2 here is square root 97 if you want to give it a try and check your answer. Alright, for midpoint. So midpoint's exactly what it sounds like. It's the point in the middle of the endpoints of the segment. So if I have a segment, okay, and I have these endpoints, we'll just say A and B. M is exactly in the middle, the midpoint of A and B. So what that creates is two congruent segments. Okay, so AM would be congruent to MB because M is the midpoint. Okay, so each side is the same length. So let's say AM was like, I don't know, 6. MB would also be a distance of 6 or a length of 6. Okay, we're going to skip midpoint on a number line. If you need to, pause the video to write this down. Pause the video. Okay,